Hi there and welcome to the first screencast of the Computing Labs for 193301. The purpose of these labs is essentially to act as a record of me working through each of the computing labs, just so that you can see how I do things, which may then help inform how you should do things. So we're going to be working through the first computer lab today. So we'll just go to Stream and we'll click on that and it loads up the worksheet. And each of the computer labs will have one of these worksheets, which basically tell us what to do. So the idea is you read through them, you download the necessary files, and away you go. So if you're using your own laptop, the first thing to do is make sure that you get RStudio installed on your computer. So you can just click on this link here to get instructions about doing that and just follow those instructions. I've already done that. I've got RStudio installed here. So I'm going to get started by downloading the first lab file by right-clicking and save link as. I'm going to put it somewhere where I know where it is. So 193301, maybe in the screencast folder here. Okay, and then I'm going to go into RStudio. This is RStudio here, and then I'll open that file just from the place that I saved it. Okay, and I get a screen that looks like this. Now, to give you an overview of what RStudio is and what the various bits of it make up, this window here is called the editor window, and it's where we'll be doing all our work basically. We may do a little bit down in this window down the bottom here, which is the console. This is the place where all the action essentially happens. This is where commands are entered and output returned to us. However, we'll notice that as we go through these documents, we don't actually need the console. We'll actually be getting things done in line. So we'll just sort of get rid of that a little bit. Up in the top right here is your environment. This stores things like data you have loaded, variables you have set, any models you fit and stuff like that will go up in here. We'll see some of that later. Down here we've got files, so you can see I'm currently in my screencast folder and I have various files here. Plots will go in here. Packages, we'll get to that in a moment, about what packages mean. They go down in here. We can install new packages from here. Help, for looking for help. That's the sort of the main ones that we need to deal with. Okay, so essentially R is a programming language, but it's a programming language that's been designed to do statistics. So common tasks in statistics tend to involve similar things to common tasks in programming. Really, you take a data set and you manipulate it in some way. You create new columns through computing based on other columns. You filter rows out. You join data sets together. All that sort of stuff, and then you get to plotting data, and altering plots and changing the aesthetics and so on of the plot in order to get the sort of the picture that you want to present to your audience. And the reason we use a programming language for this and not some sort of a point and click type thing is that it's really important that the work that we do is reproducible. And by writing code to do the work, that kind of essentially gives you the reproducibility for free, because all you do is you rerun the same code and you get the same answer. Okay, so we're going to do most of our work in what's called R Markdown documents. So Markdown is essentially a markup language, I guess is the official term for it. It's a bit like HTML, which stands for Hypertext Markup Language, and various other ones. It's basically a way that we can use normal plain text, like this is, with some special characters that designate special sort of formatting, right? So here you'll notice I've got two hashes before the introduction. The two hashes basically mean give me a heading. Okay, down here I've got two stars surrounding the two asterisks, double asterisks surrounding the R Markdown document. That means make this bold. Okay, here I've got one star surrounding the formatting word. That means make this italics. 3 stars would be bold italics, right? That sort of thing. There's various levels of heading. So this is a level 2 heading. 3 hashes would be a level 3 heading, which is a little bit smaller. 4 hashes is a level 4 heading, which is smaller again. 1 hash is a giant heading, that sort of thing. Okay, and so the Markdown is the sort of the language that we use for the text, which basically alters how things turn out when we finally produce a document from this text file here. The R bit of R Markdown is the code. So every now and then we'll see little blocks of code, which are designated by these funny characters here. That's a backtick, which is top left on your keyboard, just below the escape key usually. So 3 backticks, parentheses, and then R. Designate that this is a code block that has R in it, and you'll notice that it's got a slightly different background color. Okay, so that's something to look for when you're looking through your document, and it also has a couple of little icons here. Okay, and the main one we'll be using is the play button. Right, play button, that does is it runs the code in that chunk. Okay, so this is called an R code chunk, and playing it will run the current chunk. Okay, so when we click the play button there, we see that it has given us an answer, which is the number 23, which of course is 3 plus 4 times 5 is 23, so R can do maths. The little 1 here is the row number. Okay, so generally when we're dealing with data, we're going to have lots of numbers, right? Not just one. And so it's useful when it spits out a whole list for you to be able to identify which row is which, right? So that you can see, oh, the odd value is in the 10th row or something. Is useful information to know. So that's why it gives you the row numbers. Okay, so we'll see more of that later on. Now we can also run the code, either with the play button, or we can just be on a line, anywhere on the line, doesn't matter. I can be in the middle of it with my cursor. And if I say Control Enter or Command Enter on a Mac, it will run the code at that point as well. Okay, so R can do maths. Here's some slightly more complicated maths. We've got the square root of 25. So SQRT stands for square root. That should be 5. So I Control Enter, ran that, and it just ran that one line. So it's run the square root of 25, but hasn't run the log of 100. The next line computes the log of 100. Okay, so this is the log, natural log, so log base E, okay, is 4.6, right? If I run them both at once with the run command, then it'll give me both outputs. Okay. All right, so this next block is telling us a little bit about how we can compute things and then save them for later use. Okay, so essentially there's 2 types of sort of command or statement in R. One is an expression, like we've done above. So each of these things are an expression, and they do some computation and then give you an answer. Okay. The other type is assignment, which creates a variable and stores the results. Okay. So expressions always print the results. So when you run the square root 25, it always gives you the answer 5. Okay. Whereas assignments do not; they store it instead. So if I look down here, I see I have a line that also has 3 plus 4 times 5, which is 23, but it's putting it into the variable A. So when I just run that first line, then I get no output down here, okay? But some of you will have noticed that I've got an A up here now with the value 23. So what it's done is it's worked out the 3 plus 4 times 5 and then created a new variable called A, which it's assigned 23 to. So A takes the value 23. And we can now use A by, for instance, printing it out just by typing A, and that gives me the answer 23, right? So it knows that A is 23. So we can use the number 23 just by using A instead, right? So this next one is doing some expression here, doing some computation, 3:A, whatever that does, and it's assigning it into B. So when we run this line, we'll get a new variable B, okay, which is up here. And you can see that that variable B is a whole bunch of numbers. It's not just one. Okay, in fact, it's the numbers 3 all the way up to 23, right? So the colon here means 2, if you like. So this is saying B equals 3 up to 23. Okay, let's maybe just add a little comment here. Okay, so it's sort of a shorthand way of creating a sequence. The next command here, b times 2, is going to take that element b, that variable b, and multiply it by 2, right? So we're going to, because b consists of a whole bunch of numbers, 3 through 23, it's going to multiply each of them by 2 in turn. So you get 3 times 2 is 6, 4 times 2 is 8, 5 times 2 is 10, all the way up to 23 times 2 is 46. Okay? So when you run a command and it gives you no output, it's probably because you have an assignment. Okay, so that's not anything to worry about. If you want to see the value of it, you just type the name of the variable and run the line. Okay, so that's what b is, 3 through 23. Okay, so you can see I've got a and b up here. Okay, so this is essentially some data, but it's a very boring data set in that it's just a single variable with a bunch of numbers in it. Okay, now typically when we have data, we have multiple observations of many variables at once. So we're going to have a look at a new data set on the weight of chickens, baby chicks. Baby chicks? Baby chickens are chicks, I suppose. Data are arranged in an object called a data frame in R. And a data frame is basically like a big array or table of data. Where you have columns. Each column is usually a variable, and each row is usually an observation. Okay, so here we have some information on the weight of chickens. If I want to find out about chick weight, because it's a built-in data set, if I just put my cursor on chick weight somewhere and press F1, F1 is the shortcut for help, and you can see I've got help here. This is the weight versus age of chicks on different diets. Okay, so it has 578 rows and 4 columns from an experiment on the effective diet on early growth of chicks. Okay, and here's some information as to where it comes from down here, in case you want. So it's an example out of what looks like a statistics textbook. Okay, right. Now. So the first command here is just loading the data up. It's a data set that's included with RStudio. So the data command is used for retrieving data included with RStudio. Normally we'll be using data external to RStudio that will read in. So we'll see that in the lab 3, I think, is the first one that we read data in. The head command then just shows us the first 6 rows. Okay, so you can see here we have 6 rows. And here they are. Okay, we could of course just dump them all out. There's all of the rows, okay, arranged in a thing that we can kind of click through. Okay, so you can see that there's 4 variables: the weight, the time, the chick, and the diet, and 578 observations on those variables. If we want to see the data in sort of a spreadsheet form, we can double click on the chick weight up here. Or actually just single click on the chick weight by the looks, and then we can kind of search through and see all the weights at once. So what we see as we're going through here is that we've got multiple measures per chick, right? So this first chick number 1, was measured 12 times over time. So measured at time 0, 2, 4, 6, 8, 10, 12, every second day up until day 21. And chick number 1 was on diet 1. And I guess eventually we'll find some other diets. Yeah, so here's diet 2. Okay, so chick number 21 was on diet 2. And then I guess there'll be further diets further down. Yeah, so diet 3 and so on. Okay. Right, so the head command's kind of useful just to look at the top of it, just to kind of check that everything's how you expect it is. Okay, and now of course we have chick weight up in our environment under the data tab. So R distinguishes variables that just have numbers in them. Sort of vectors of numbers, I guess these would be, into and shows the actual data sets as a separate feature. Right, so that was the head command. What do you think the tail command will do? Presumably, instead of the top of the data, it'll take the back end of the data. Right, so these rows 573 through to 578. Okay. Now we could also get this from the help for head. So if we press F1 on head, we'll get the help for head, and you can see that there's all of this info here. Now this is kind of important to look at, just in terms of what it might show, just so you get used to basically looking at help. In general, the help in R is an acquired taste. You get used to it after a while, but at first it's like, what does this even mean, right? You've got all of this complicated usage stuff. What I spot here is I spot n equals 6 with an L, whatever that means. And given I've already run it and it gave me 6 rows, maybe that suggests that if I go n equals 10, I'll get 10 rows, right? Tail has a similar format, and I see down here is n, an integer vector of blah, 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 blah. Quite a complicated looking thing, right? There may be some examples further down. So right down the bottom, there's some examples where I could try these things out to see what happens. Okay, so often when I'm looking for help, if I know the name of the function and I've got the help on the function here, then I'll look down at the examples first to find one that's kind of matching what I want to do, and I'll copy and paste that, figure out how it works, and then sort of adapt it to my needs. If I'm not sure about the function, or I don't understand it after looking at the help, then what I'll do is I'll just Google it. So what I'll do is I'll just type in, how do I find the first 6 rows of a data frame in R? That's exactly what I would type into Google. Okay. Adding in R is really important to help Google focus your results. That's the basic idea. So another useful command is summary. So let's run that one and see what that does. And so that basically summarizes each column in turn. Okay, so you can see that the weight column and the time column have been summarized using the 5 number summary that we talk about in lecture 1. The minimum, the first quartile, lower quartile, the median, the upper quartile, and the maximum, and the mean. So the 5 number summary plus the mean. And that's because those columns are numeric. Now, interestingly, these last 2 columns, the chick column and the diet column, they're also numbers, right? But RStudio already knows that they're not supposed to be interpreted as numbers, because this is, of course, is the chicken. So it could be the name of the chicken instead, the name of the chick instead of the number, and similarly the name of the diet instead of the number. So it knows that those are categorical, and it has summarized them in a different way. So to summarize categorical information from lecture 2, we use a table, right? So that's what it's done here for the diet. It's told us how many rows are in each of the diets. So you can see here that in diet 1 we have 220 observations, in diet 2 120, and so on. The same thing has happened with the chick, right? So chick number 13 has 12 observations. Chick number 9 has 12 observations, and so on. Now the order that you get might be slightly different to the order that I get. It kind of depends a little bit on the time that you run it, because there's a random number generator in RStudio, okay? But you'll get the same information, it just might be arranged a little bit differently. Okay, so now for plotting, the first thing we notice is that we've got quite a lot to write when we do a plot, okay? And this is because the plotting package that we're using, which is called ggplot2, is extremely flexible and can do some quite cool stuff, which we'll get to later, but it does mean that the learning curve is a little bit steeper, or at least the amount of typing that you have to do is a little bit steeper, but it follows the same recipe. Okay, so if we kind of remember the recipe, then we can kind of regenerate a plot for a different data set, just by following that same recipe. So the very first thing we do, and we only have to do this once in each time, is we load the library ggplot2. Okay, now if I didn't have ggplot2, when I ran that I would get an error. When I run this myself now, I don't get an error, right? So that's fine. If you're running this on your own computer and you get an error when you run that command, it's just because you don't have the package. Now you might get prompted when you load up the Markdown file. There'll be a wee yellow bar up the top saying something like, this file uses ggplot2 and it is not installed. Would you like to install it? Just click yes, right? If you didn't do that when it happened or it didn't pop up for whatever reason, just click on the Packages menu, Install, type in ggplot2, try not to spell it wrong, and then Install, and away it will go and install it. Okay. Once done, the ggplot2 package is loaded and the ggplot line then runs. Okay, if you haven't run the library ggplot2 line, then the ggplot line will return something like unknown object ggplot. Okay, that's because it doesn't know about the function ggplot. It's loaded once you load that package with the library ggplot2 command. Okay, so let's have a look at the structure of this piece of code. There's basically sort of 3 or 4 ingredients. The very first thing we do when we're creating a plot is we do ggplot. Right, and then after we've typed ggplot, we have to tell it what data we want. So that's what data do you want to plot. So here I'm said the data is equal to the chick weight. That finishes the ggplot bit. So if I just run that bit by itself, let's put that on a separate line and just run that bit, then what I'll get is just a blank plot, right? So at this point, it knows it needs to create a plot. It's done so, and it has associated the chick weight data with that plot. Okay. The next bit is, what do I want to plot, right? So in this case, I want to do a scatter plot, so I'm going to be using geom_point. Okay. Now a couple of things happened there when I was typing that. Let me do that again so you can see. So as soon as I type geom, I get a pop-up which lists all of the different things that start with the letters GEOM, right? So these are all the different sort of geometric features that we can have on our plot, and that's kind of a handy thing for making sure everything is spelt correctly, right? And it also works for other stuff that you have loaded. So for example, as I was going data equals, if I go data equals chick, right, it pops up chick weight, and I can then click on it, and I don't have to worry about making sure, messing up the spelling of weight, or the fact that, chick, that the C and the W are uppercase characters, R is case sensitive, so it if I get that wrong, it'll produce an error. So that's kind of a helpful thing to look for that. Tab can also help. So if I'm just kind of typing away and I'm not sure if I've got enough yet, if that thing doesn't pop up straight away, then you press tab and it will prompt you for those possibilities. It pays to write out as much as you can first, so that your number of possibilities is reduced down and you don't accidentally select the wrong one. Okay, so I want points. Notice I've got a plus here. So everything in ggplot, you start with the ggplot, then you add on functions one by one. So we're going to add on a layer of points, and then I've got to tell it, what do I want on the x-axis, what do I want on the y-axis, right? So if I run this by itself, it's going to complain, and then it says it's geom_point requires the following missing aesthetics x and y. So aesthetics are features of the plot, okay? So for example, the x-axis and the y-axis. Or it might be features of the points on the plot. So for example, the size of the points, or the shape of the points, or the color of the points. Those are all aesthetics of the plot, okay? And we need to tell ggplot where we're getting those features from. So in this case, I'm going to tell it, I'm going to define a mapping using the AES function, which is short for aesthetics. And I'm going to say that the x is equal to the time variable and the y is going to be equal to the weight variable. Okay, you remember you can just click on chick weight in order to see what the variables are. So notice time is a capital T, weight has a lowercase w for some bizarre reason. Okay, so the kind of the recipe is ggplot, data equals your data set, plus the type of thing that I want, the type of geometry that I want to use, so in this case geom_point, and then the mapping from features of the plot, the x and the y, to features of the data, time and weight. Okay, that's the recipe. All right. And notice I've done it twice now, so if I run it, I'll get two plots, which are of course the same. Okay. Right. The next bit's just all explaining all that, and then this next bit down there says we can add new aesthetics to this plot, right? So we've got the X and the Y defined, but there's no reason why we can't have more, such as we could define the color of the points to map to the data as well. And so this adds an extra bit. Let's put that on another line just so that we make sure that we can always all see it. ggplot, the data is from chick weight. We're mapping X to time, Y to weight, and the color to the diet. And so we get that plot there. So whenever you map a feature of the data to features of the plot, it always gives you a scale. Okay, so for the X and Y, obviously, it gives you your X and Y axis. It tells you what the values on each axis represent, what the numbers are, and when you map the color, it's given you a little guide here, or a legend, telling you which diet is which. Okay, so the red one seems to be diet 1. That seems to have chickens that are lower in weight on average. The purple one and maybe the blue one are the ones that are higher on average, right? That diet 3 and diet 4 seem to be heavier on average than diet 3. And of course, there's this one set of points through here of the green one that is very, very low weights. Okay, that might be the same chick, I guess, through time, right? Because we've measured each of these chicks through time. Okay, so alternatively, we can use other things. So instead of color, we could use shape. Okay, and it'll change the shape. Or we could do both. Okay, so color and shape have changed, which might be good if you were printing it out or something, I suppose, on a old school black and white printer. You'd still be able to differentiate things a little bit, even though it's going to be a bit hard because all the points are on top of each other anyway. Okay, now because we actually here have the same chickens measured over time, we might want to actually link up these points with a line plot, with lines instead. So instead of using geom point, we might like to use geom line, which is basically going to link the points up with a line instead of marking them as points. So we might try that just by changing the point to line, but we get a very odd looking plot, right? This doesn't look right at all. We've got these vertical lines here which don't make any sense. And that's because it's basically just created one line per diet. Okay, so there's a single red line starting on this side and going all the way up here, even though there's of course a lot of spread for the individual chicks on that diet. So all it's done is it's basically just linked up all of the diet 1 points regardless of which chick it is. Okay, so it hasn't grouped by chick first or anything like that. Okay. One way to fix this is to make sure that we have chick involved, right, instead of the diet. So if we were to plot chicks, okay, then there it is there. Okay, so that's a plot of all of the different chick weights. So here, exactly the same as we had before, but instead of colouring by diet, we're colouring it by chick. Okay, now this again isn't all that useful because we don't know which chick is on which diet, right? The primary question here is probably, do the diets make a difference? Obviously, we know that chicks are going to make a difference. They all start at a similar weight, which is nice, but they all have different growth patterns, right? So some of them do better than others. And what we really want to know is, are those differences associated with the diet? We can't tell that from here because we don't actually have the diet marked on here. Okay, so instead, we could colour it by diet and group it by chick. So this is a common thing when you're doing a line plot like this, is that often it'll just try and join every point up. And if every point doesn't make sense to be joined up, you just need to tell it that actually make sure you do the lines within the particular groups that I want. So I'm going to group the lines by chick. And now we get something that kind of looks a little bit better. So we get one line per chick, but it's coloured by the diet. So again, we see the red ones tend to be lower. Right, so that's the first diet. The blue ones seem to be the highest, and then the purple and the green, with this one green character down here not doing terribly well. Okay. Right. So at this point, we might want to make the plot look a bit prettier than this. The obvious thing to do is to try altering these colors. So the default colors aren't particularly useful, particularly if you want to print it out. If you print this out on a black and white printer, all of these colors will look basically the same. They all have the same saturation. The only difference is the hue, which is like the color around the color wheel, if you like. The intensity, the saturation is the same for all of them. So when you print it to black and white, they're gonna look all really, really similar. So how do we change colors? Well, we can change colors plus lots of other stuff. Okay, so I have an example down here. We'll go through it in a moment. Let's just run it and see what happens. There we go. We've got different colors, and we've got some other things, don't we? We've got a title here, and we've got a different Y label, right? It was just weight with a lowercase w. Here it's weight with a capital W and a gram. In fact, I think I'd actually write this a little bit differently. Instead of using ylab and gg title here, let's just use the one function labs. So labs is a function that allows you to change all of the labels. So we can say the y equals the weight in grams. The title is equal to, grab all that stuff there. I think that's a little bit more obvious. Right, there we go. And you can change X as well, right? So X could be days. Here we go. Okay, so the code for producing the plot is the same, but we've just added on extra stuff to change other things like the color and the axis labels. For the color, we use scale color manual. So you remember that I said that when we added color, then there was a scale associated with it. So there's an X scale, a Y scale, but also a color scale here. Okay, that's why all of them start with scale. Okay, so scale color changes the scale for the color aesthetic. Okay, and there's other ones. So there'll be scale shape, for example, for changing the shape guide. And then the manual specifies that we want to basically tells it that we want to change the colors ourselves. So specify the colors ourselves. There's a whole heap of other ones. So if we press help on the F1 on the scale color manual, it'll, we can see some other ones. So these are, so that's for different things, but there'll be other ones for scale color. Not sure if we can see that down here. There's some other examples. No. So there's other ones. I guess we could see them if we just go scale color and then press tab. Yeah, so these are all the other ones we can do. So some of these, are used. So there's scale color gray, so that's for a set of grays. Scale color hue to change it just based on the hue and not the intensity. Gradient for a gradient, and so on. There's a whole heap of different ones. Brewer is a bunch of kind of predefined palettes. Okay, but scale color manual is to specify it ourselves, and then we can basically just have to give one color per group, one color per diet. Right, we've got 4 diets, therefore 4 colors. And R knows a bunch of colors, so it knows what pink is. All right, so feel free to try. I don't know if it knows what dark pink is. No, it doesn't know dark pink. Purple, I guess, is kind of a dark pink. All right, so feel free to experiment with different colors. If you want to know all of the colors, then just type colors. Hang on a sec. It's a function, so put the brackets. There we go. These are all the colors that R knows about. Okay, lots of grays. Okay, seashell. What's that look like? Let's try that one. Seashell instead of Okay, so she shell is that kind of like pale colour, which isn't that useful, I suppose, with a grey background. But anyway, that's the idea. Okay, so feel free to kind of experiment a little bit, change the colours around as you want. If you want to, try changing the shape. Right, so shape, we could change the, we could add points maybe as well as lines. Oops, let's grab that, put that there. Right, so we've got points joined by lines, and we could change the shape on those points. Okay, lots of things that you can potentially do. So kind of have a play, see what you come up with.